Okay, so the next problem is Unit 10, number 6. So it says consider citric acid, which is H3C6H5O7. And then it asks at what buffered pH would H3C6H5O7 citric acid and its conjugate base of H2C6H5O7 minus have the same concentration. So here again, just kind of looking at what we have or what we're trying to find. We're trying to find pH. And we know that citric acid and its conjugate base are going to have the same concentration. So just based off of that, I would say using the Henderson-Hasselbalch equation is our best bet to approach this problem. Honestly, any buffer problem, you're going to want to look at this equation first because it's really simple. So it's asking us for the pH. We know pKa because we know we have citric acid. So over here, citric acid somewhere, citric acid Ka1 is what we're working with because we're going from H3 to H2. So 7.4 times 10 to the negative 4th. P is negative log. So negative log of 7.4 times 10 to the negative 4th. And then again, it tells us we want the pH where these two, the citric acid and its conjugate base, have the same concentration. So as in problem 2 and 3, this here is 1 and log of 1 is 0. So we can just get rid of that term. So pH equals negative log of 7.4 times 10 to the negative 4th. You just do that math, you find pH equals 3.13 when citric acid and its conjugate base have the same concentration. Now part B asks, what is the predominant species present at a pH of 8? So this is how I always set up the problem. Here, because we know at what pH all of these two species have the same concentration, right? Because of this Henderson-Hasselbalch equation. We can do this same thing using Ka1, Ka2, and Ka3. Ka1, when you use the Henderson-Hasselbalch equation, which is what we just did in part A, that's for H3 to H2, and we know those two are at equal concentrations at a pH of 3.13. You use Ka2 to find where H2 to H are at the same when they have the same concentration at which pH, so that's 4.77. Again, that was just using the Henderson-Hasselbalch exactly like in part A, except I used Ka2. And then here, again using Henderson-Hasselbalch, but with Ka1 because I'm going H to no H, this is the pH at which they'll have the same concentration. So then it asks us, I have a pH of 8. Which is the predominant species? So then it's really easy. You just look, okay, 8 is after 6.4. So that means this is the predominant species. So anytime you get a question like that, just write out all of the possibilities of your acids and bases here. Find the pHs at which they're equal. The concentrations are equal. So just using Ka1 here, Ka2 here, and Ka3 here. And then just find where your actual pH compares to this ranking. And then you know what your predominant species is. So pretty simple, but you just have to know this little trick.